So now we are going to start with our next topic, which is small angle approximation. Okay, and then we are going to see a topic little bit different from the trigonometry. Okay, that is binomial approximation. So let's first focus on the small angle approximation. So I am saying here that if the angle is less than 5 degree, if the angle is less than 5 degree, then we can apply the small angle approximation. And what is it? Small angle approximation says that if you have sine theta and theta is less than 5 degree, then you can directly write it theta. Okay, but theta now it is in radian. When it will come out of sine, it should be in radians. Okay, radians means I have taught you in the first lecture, that is pi by 180 you have to multiply by the factor. So when you are checking the angle, you have to check in the degree that it should be less than 5 degree, but when you are taking out of the sine, then you have to make sure that it should be in radians. So okay, and this is cos theta, you directly write down 1, and tan theta, just sine by cos, if you see directly it comes theta. Okay, how it comes? So you know, like here from angles, from it comes when we wrote about the circle, like pi r length, that how much is the arc length, that is theta into r. That's how it comes somehow. Okay, we don't have to go in the proof. So that's all. This is the small angle approximation, and this is also very important, and we use it very often. Okay, and so next we're gonna see the example sine 0.6 degree. Okay, so 0.6 degree is, so basically 0.6 degree is less than 5 degrees, so we can use the small angle approximation. So sine theta is theta 0.6. Now this is the gonna mistake that you're gonna make. Okay, this is degree, so you can't take out in degree, you have to convert into radian. So this, the factor of pi by 180 is gonna come here. Understood? Okay, I hope you will remember this. So this is small mistake which students make, it directly take 0.6. Okay, you compared it with 5 degree, but when you are taking it out, you multiply with it pi by 180. Okay, next question we have, this length is given x and this length is given 7200 by pi, and this angle is given theta, that is 2 degree. Okay, now from this triangle I can write tan of 2 degree, that is equals to x by 7200 by pi, right? Okay, and we know tan theta, if theta is less than 5 degree, I can apply approximation. I can write 2 degree into pi by 180. Okay, so this is gonna come, and if you solve this 7200, so this is gonna come x is equals to, I can say 80 meter. Okay, this is 7200 pi. If it is given in meter, this x is gonna also come in meter only. Okay, now let's see some examples. Okay, we have two more questions here. Now see, sine 1 degree divided by cos of 0.5 multiplied by 1 by tan 2 degree. Okay, now how to solve this? So sine 1, I can say, I can directly apply approximation. So I can directly write sine theta is equals to theta, that is 1 into pi by 180. Okay, and then I apply cos 0.5, so I can write directly 1 multiply by, okay, 1 upon tan 2 degree. So tan 2 degree is 2 into pi by 180. Okay, this is, and this value is gonna come 1 by 2. Okay, next question we have sine of 1.5 degree divided by 10.3 degree multiplied by cos of 0.2 degree. Okay, so this all are less than 5 degree, right? So I can convert it into approximation. I can apply everywhere, and sine 1.5, that I gonna see here is sine 1.5 into pi by 180 divided by tan, that is 0.3 multiplied by pi by 180. Obviously you have to remember that we have to convert it to radian, multiply by cos of 0.2, that is 1. Okay, so if you solve this 1.5 by 0.3, that is 5. Okay, I hope you have got this both examples. Okay, now next our topic is very small, so we're going to cover in this video only. Okay, and what is that? that is binomial approximation. Okay, this is very important, and we apply it very often. Okay, and we use it like every whatever I am teaching you in mathematical tools, we use a very little bit of that, and but we use it every single time. Okay, we'll use it. This is the basic things, okay, which we use in the physics. Okay, that's why we are teaching it before the start of our main chapters, so that you can learn it before we go into deep into the physics. Okay, so that we don't have any problem when we are teaching that. Okay, now let's see here. If the expression is given like this, 1 plus x to the power n, then you can write it directly 1 plus nx. If x is very less than 1, okay, if here x is very less than 1, then you can directly write it 1 plus nx, and if there is 1 minus x to the power n, you can write 1 minus nx. Okay, now see one example how we are applying that. So here it is given 99 to the power half. Okay, just leave the degree thing. Okay, 99 to the power half. Can I write it 100 minus 1 to the power half, right? Okay, next let's see, take 100 common, so this is going to be 10, and 1 minus 1 by 100 to the power half. So compare to 1, so here what is the x? If you compare, what is the x? X is equals to 1 by 100, and we know 1 by 100 is very less than 1, right? 0.01 is very less than 1, 100 times less. Okay, so here I can apply the small angle, this binomial approximation, and I can write 10 into 1 minus nx, that is n is half, into this 100. Okay, and what this value gonna come? 200. So this is gonna come 199 by 20, I can say. Okay, so this is approximate value. If you calculate directly under root of 99, this is very close to that. Okay, so this is approximation, not exact value, but you can use this method to calculate. Okay, how it comes? Just the expansion of 1 plus x to the power n, that is here more terms come, but because x is very less, so square of that is gonna come very less, so we ignore those values and we can write it like this. Okay, this expansion is also expansion, and proof of the expansion comes in mathematics. Okay, and we can go, you can go for proof there. Okay, so you will learn proof that, don't worry about that. Okay, so this is how we do. Next question, if we see one more example, what we see here is 1001. I hope you will able to write it 1000 plus 1 multiply by 1 to the power 1 by 3. Okay, now if you take 1000 common here, it's gonna be 1000. How we take common? 1 by 3, 1 plus 1 upon 1000 to the power 1 by 3. Okay, so 1000 to the power 1 by 3, that is 10, and 1 plus x to the power n, so I can write 1 plus nx. Nx is 1 by 3 into 1 by 1000. Okay, is equals to 3000. This value 3000 divided by 300. This is your answer. This is very approximate. If you calculate, it is not the exact, but these values are very approximate. You can write it like 1000 to the power 1 by 3 directly, 10 came, but that is not very close. Okay, this is more closer to that. Okay, that's why we use binomial approximation, and there is a whole chapter in the mathematics which name is binomial theorem. Okay, and all we talk about this kind of expressions only in that chapter, and you're going to learn more in that chapter. Thank you.